Hi everyone, today I'm going to be solving the Leetcode question, search a 2D matrix. So the problem is telling you to write an efficient algorithm that searches for a value target in the m by n integer matrix. And you're told that it's already sorted, so the elements are sorted from left to right, and the first integer of each row is greater than the last integer of the previous row. So if you see here, the matrix is like sorted 1, 3, 5, 7, 10, 11, 16, 20, 23, 30, 34, 60. And you're trying to find out if a value is in that matrix. So you're given like 3 in this matrix, which is there. And then you're also given 13 in the next example, which is not in that matrix. So this is the problem. And since the array is sorted, it already gives you an idea of using binary search, which is a way that you can solve this problem. But because it's a 2D matrix, it's a little bit complex to do that. Um, so let me just go over a couple approaches to solve this problem. And I'll switch over to my iPad to show you a couple ways you can do this problem. The first one is the most basic brute force, which is n square, where you will just be checking all the rows and all the columns, so and then seeing if there's a value. And actually this is not n squared, it would be if there's n rows and m columns, it would be n times m. So that would be the most basic solution. Second solution is you can actually use the fact that the array is sorted, and the way you can do that is if you start off at 8, you will notice that all the elements to the left of 8 in that first column are smaller than 8. And if you go down, all of these elements, so basically like to the left, all of these elements are smaller, and down are all these elements are greater. So if you just start off at 8, at which is like the first row and the last column, you can basically just make it a linear time, which would just be n plus m. So for example, like if we're trying to find 11, what you can do is you can first start off at 8, and then you'll see that 8 is smaller than 11. So what we'll do is we'll go down and we'll see 20. And then once we see 20, we see that 20 is greater than 11. So we'll go to the left. And then we'll reach 16. And we'll see that 16 is is greater than 11. So we'll go to the left again. And then we'll get to 11. So that's how you find it. And basically any number, you can do it with this n plus m complexity. So for example, like if we're trying to find a number that is not in the matrix, like let's say we try to find like 40, what we'll be doing is we'll go to 20, and then we'll see that 20 is smaller than 40, which is the target. So what we'll do is we'll go down again 60, and then we'll go to 34, and then we'll see that it's greater, that is less than 40, but there is no down, because we'll go down and then we'll reach the end of the matrix. And when we have this condition, we'll know that we can't find the value, and then we'll just return false. So that is a way that you can solve this problem in linear complexity instead of the quadratic that we found before. And there's actually a better approach. So the final solution, which is the best approach, is to use binary search. So binary search is going to be a log n plus m solution, because the array is already sorted, like it's 1, 4, 7, 8, 10, 11, 16, 20, 23, 30, 34, 60, like all of these are already sorted. So what you'll have to do is you just have to modify the original binary search that we're typically used to use this logarithmic complexity. and I'm going to show you how I did that because that's the best approach to solve this problem. Okay, so this is how I solved this problem using logarithmic time. Um, so it's basically binary search, but you have to um, try to make it into a 2D matrix. So it's very similar to the regular binary search. So first, I'm getting these variables to get the matrix length of the rows and columns for so m and n, and then like in typical binary search, I'm setting the left equal to 0, but for the right, I'm doing m cross n minus 1. So because it's basically like this where we have 1 3 5 7 10 11 16 20. So the last index is the right, and it's going to be the greatest element, and then what I have is two different mids. So typically in binary search we'll just have one mid element, like we would just do left plus right divided by 2. But in this case, there's a linear mid, and then there's also a matrix mid. So the linear mid is what is the regular mid that you would be used to in binary search, but then you have to convert this into the matrix value, and that's why I have this matrix mid variable. So how I did this is that I first do the linear mid, which is just the regular binary search, left plus right divided by 2, then matrix mid. Um, so to find the row, you actually have to divide by uh, the number of columns, like in the linear. So you do divided by n, and then you have to do modulo n to get the column number. So that's how it's like split up when we do m times n minus 1. And like when you actually get it into the to get the values in the matrix, you have to do these conversions, and then so that's the value that we use based on the linear mid. And then if the target is equal to that, then we return true, which is regular binary search, and then um, we check the other two conditions. So if it's less than, then we do the regular linear mid minus 1, and then left, on the other case, it would be plus 1. So this is just basically the same as binary search. And of course, like if we can't find the value, we return false. So the main thing of this, the only difference between binary search and this problem is this conversion. And this is only specific to matrix problems. But like once you understand this conversion, this problem is very straightforward. And once I submit this problem, you can see that it's accepted, and I'm getting a runtime of 100%, which is very good. So thanks for watching this video. Let me know if you have any questions about the solution, and subscribe for more videos in the future.